Hi, my name is John Twist of University Motors. Today is July 5th. I hope you took the opportunity yesterday to print out a copy of the Declaration of Independence and at least read the beginning and the end of it. Maybe the whole page of complaints against King George was a little too much, but it is an important part of our history. But that's not what I'm here to talk about. That was yesterday. Today I'm talking about Midget 1500 engines. Now here this one's upside down, and the reason that it's out of the car and back here in this world of engine parts is because it came apart. It was running down the road at highway speed, and this rod cap came apart. The crank came around and hit it, and it's jammed up and caused extreme damage to the crank and to the rod. So we took it apart and we cleaned it up, only to find out when the Bondo popped off the side of the block that this had happened once before, but not to number 3, that time apparently to number 4. And that must have punched a hole in the side, and someone, a very laborious process, jammed it all together, brazed it all up. There's a piece of sheet metal on the inside you can't see from here, but this is a pretty amazing repair. We're not going to use this block when we go ahead and rebuild the engine, of course. Let me show you some of the yucky stuff that came out of this. First of all, we have our oil pump, you know, but that's remained relatively undamaged. Here's the rod cap, and the rod cap is what came off. And here's one complete rod bolt here, and we probably have a broken bit of rod bolt. Yes, here's a broken bit of rod bolt here. So what happened was this thing was rattling. It began to rattle because the bearing failed, and as it rattled, then things stretched. The bolts stretched, and once the bolts started to stretch, they unwound. I've discovered in 40 years of doing all this stuff that when bolts rattle, they always rattle loose. They never rattle tight. Here's the rod bearing. I don't know. You don't need to be an engineer to know that something's terribly wrong with this rod bearing. It's also, here's another part of that same bearing. I mean, this really is a beautiful example of what happens with the Midget 1500 engine, because it did fail on number 3, which is the common place for it to fail. Here are the thrust washers. It's not uncommon for the Midget to throw the thrust washers. Certainly in this case it wasn't. What else have I got down here? I still have little bits of, rod bearing and sleeves from the bolts, and of course the whole bottom of the sump. The whole bottom of the sump is just filled with metal and crud. Look at this. This is all rod bearing, huh? Hard to believe it's been hammered so, but when you take a piece of metal and start pounding on it, like the rod was pounding, for an indeterminate amount of time, but probably a couple of minutes, at every pound it makes the metal a little thinner, which makes the metal a little bit bigger. So this is quite a dramatic failure. As I said, we're not going to rebuild this engine, but if we were, these are some of the things that we would do. Let's store the sump up out of the way here. There's an oil gallery that goes through here and comes up and feeds the center main. There's an oil gallery that comes through here and feeds this main, and in the back it feeds the rear main. Now all 3 of those galleries are 1/4 inch. This gallery feeds a main and a rod. This gallery feeds a main and a rod. But this gallery feeds a main and 2 rods. So it's very, very common for this engine to fail either on 2 or 3, good example here, because it starves for oil. So when we rebuild the engine, we open this up here and re-drill this oil gallery 5/16. The difference between 5/16 and 1/4 inch is about double the cross section. So it's going to carry about twice as much oil. In addition, we work with the back of the block where the thrust washers are, so that we put 2 thrust washers on the back side of the rear main cap, so that when you're pressing on the clutch and the whole flywheel and the crankshaft are pressed forward, they're pressing against 2 thrust washers. We only leave one on the front side here because there's hardly any pressure pushing backwards. The workshop manual calls for an end float in this engine of 10 to 12 thousandths, which is a solid 7 thousandths too large at least. I like to see an end float more of 1 to 3 thousandths of an inch. When you're going to rebuild this engine, you recircle all the rods, you align bore the bottom end, you add that extra thrust washer on the back, and you increase the diameter of the oil gallery here to 5/16, and then you can end up with a pretty good engine. But as they sit, the Midget 1500s, they're pretty weak. There's a lot of stuff that can go wrong with them. Next week, I won't be talking so much about Midget 1500 engines. I'll be talking about MGAs, because I'm going to be in Dayton, Ohio at the NAMGAR, the GT number 37. You can find that, just go on the web, Google NAMGAR GT 37. Up you come with their website. It's going to be a really good time. I'm going to fix cars on Thursday, so it'll be really hot. Today it's really hot. It's like 100 degrees in the shade, and it's supposed to be just as hot next week. So it'll be interesting to see how all these MGAs, whose owners always complain that they run too hot in the cockpit, and most of the MGAs can run pretty warm at the thermostat too. So we're gonna have a lot of fun next week with overheating. Hey, until the next time, see you later.